Okay, so I'm gonna draw a diagram here, and I want you all to forget about maths and just think about it logically. So let me just say I have A, B, C, and I have D, right? I'm going to connect these points. Could anybody in class tell me how I could go from A to C? Is there anybody in class that could tell me how to go from A to C?
Yeah, yes, sir. You go to A to B, then B to C.
I just alright. I say you don't know nothing about vectors. Let me know if that makes sense at least. So like we traveling, right? We hop in our car and we traveling, right, Jazara? So you at A. Jazara, if you're at A, how would you reach C? Talk to me. How would you reach C? Can I hear Jazara? But guys, it's very, very simple. If I want to go from A to C, I go from A to B and then B to C. And that would carry me from A to C. So if I were to draw that as a vector, it would look like this. And to go from A to C, I had to go from A to B and B to C. Once you could understand this simple concept, you're covered for like most of vectors. Everybody understand the simple concept? A to C.
Yes, sir.
Okay,
Yes, sir.
are we done yet? Guys, is that the only way I could reach from A to C?
No, sir. You go to A to D, then D to C.
Like what we talking about? A to C, I could go from A to D, and then I could go from D to C. Well, check that. A to D, and then D to C. So it making sense. All of these are alternative ways you could go from A to C. That is like the foundation of vectors. Foundation. Now, what are some things you should also know before continuing? You should know what parallel vectors are. A lot of students ask me about this. Parallel vectors, what is that? So let me show you now. So when I hit it with parallel, what comes to mind? Parallel.
Two
Anybody?
lines that touch,
Two lines that
never meet or never touch.
never meet or never touch. And would you guys say that they have the same gradients or different gradient?
They would
Same
have
way.
different gradients.
If I have two lines and they are parallel, they would have the same gradient. Cool. Now let's think about it simpler, right? Okay. Look at this. I'm going to try to make it as simple as possible. So I have a point in space here. I call this A and I call this B. Everybody understand that? So like that vector over there carrying me from A to B. Are we seeing that, right? This vector carrying me from point A to point B. Bam. Let me just say I had another vector. And this vector is C to D. What you notice about those two vectors? Did anybody tell me?
They're parallel, so
Anybody else seeing that? I find the place real quiet. The money follow agree that those are parallel.
Yes, sir.
Yes, sir.
Parallel.
Yes, sir.
yes, sir.
Let me check something out, right? If I were to take this vector and I were to place it here, wouldn't it line up? Well, it technically should, right? Wait. What? Check this out. Are you seeing that with your own eyes, right? Let me know if you seeing what I'm talking about.
Yes.
Okay. So I'm gonna try to make it a bit more intuitive for you guys. Check this out. So Akira, these two vectors are what? What are those two vectors?
Parallel.
Parallel. And how much of ABs do you think it might take to make CD? Like if you had to say,
2.
it's taking two. Now you're probably saying, sir, where you on about? Where you going with this? I'm here what I'm saying, right? If you want to show that two vectors are parallel, you need to be able to show that they are scalar multiples of each other. That's what you need to be able to do. That is what you need to do. Give me a second. Give me a second, guys. Let me just close this thing off. Quit. Work, please. Give me a second. Any minute now. Right. So here what? Could everybody in class see that these two vectors are parallel? And could we also see that AB looks like half of CD? Let me know if you let me know if all could see that.
Yes,
Yes,
sir.
sir.
All right. So two vectors are parallel if one can be written as a scalar multiple of the other. Now, does it mean that these two vectors start at the same point? Yes or no? Somebody in class tell me, do these two vectors start at the same point?
Yes, sir.
Yes, sir.
Wait, I'll say yes, but I see this one starting at A and going to B, and I see this one starting at C and going to D. How will they could say they're starting at the same point?
Oh, you mean it like that?
Yeah. So two vectors could be parallel, but not starting at the same point. In that situation, you would say they're parallel alone. You would not say they're collinear. I'm moving on to collinear just now. So let me look at something, right? Let's look at something. Suppose this was 1 and this was 3. Okay. And suppose that this was 2. Let me just make this a bit bigger. And let me just say that this was 6. Let's take a second. So here what I'm doing, right? I'm just trying to show you all this logically. Could anybody tell me what vector A to B might look like? Okay, well, it probably can't do that right now because of the diagram. So here what? I could just give you I could just come up with something quickly. So let me just say that this vector, we could probably say, I could probably say, I could say 2 here and 3 here. All right, and for this vector, I could probably say that this is 4 and this is 6. So what would that mean? You're probably saying, well, so what does that mean? So what I'm saying is, if I want to go from A to B, tell me, Romano, if I want to go from A to B, I need to take 2 units to D. This is our
Right
example. But Romano, look at this. If I wanted to go from A to B, I would have to move 2 units to D,
to the right.
and then how much up?
Um, 3.
3 up, right? So A to B would be represented as 2, 3. Okay, cool. Using that same logic, could anybody tell me what vector C to D would be?
4, 6.
Exactly. Good job, Joshua. Now, is there a way I could write AB in terms of CD? Or is there a way I could write CD in terms of AB? Well, look at it for yourself. Look at this for yourself. It sort of looks like AB is what of CD? Twice.
Huh?
Half.
It kind of looking like AB is a half of CD. Do you
Yes.
think I'll be able to prove that with these numbers?
Yes, sir.
Well, let me try it now. So you need to be able to show it mathematically that way seeing makes sense. So I'll tell them that AB is what of CD.
Half?
Okay, well, let me justify that. So we're saying that AB is a half of CD. We know that vector AB is what?
2, 3.
2, 3.
And vector C to D is what?
4, 6.
Okay. Anybody in class, what is a half of 4, 6?
2.
2, 2.
So were we able to write AB as a half of CD?
Yes.
Yes, sir.
Okay, let me try the other way around. Another way to think about this is that AB is how much time, okay, how much ABs would make up CD?
2.
2. Everybody can see that, right? So it would take 2 ABs to make up CD. Let me know if all you see now.
Yes, sir.
Look at it for yourself. Right, Akira, let me know if you're seeing that. Can you see that it would take 2 ABs to make
Yes, sir.
CD? You sure you understand that?
Yes, sir.
Okay, good. So we're saying that CD would be equal to how much ABs? Tell me, Akira.
2.
Let's see if that's true. C to D is what? What vector is C to D? What vector is C to
4,
D?
4,
4,
6.
6, right?
4,
4,
6,
6.
right? Remember, a vector consists of a horizontal component, so either left or right, and then a vertical component, either up or down. And we're saying that that would be equal to 2 times AB. Where's AB? What is
2,
AB?
3.
2, 3. If I multiply 2 by 2, 3, what are we going to get?
4, 6.
4, 6.
And is 4, 6 equal to 4, 6?
Yes, sir.
Right. So in doing this, we were able to say that, AB could be a half of CD, which we saw that. And then we also could have say that CD is just 2 ABs. So anytime you could write 2 vectors in terms of each other, where one is a scalar multiple, it means that they are parallel. It does not mean that they are collinear. You'll see what collinear means just now. But once you could write 2 vectors or scalar multiples of each other, it means they are what? Somebody tell me. Anytime I could write a vector as a scalar multiple of another, it is
Parallel.
parallel. Parallel. So maybe I should give you guys some more examples. And this is the scalar multiple thing I'm talking about. So, Romana, you see how I'm multiplying CD by a half?
Yes, sir.
That means I'm multiplying it by a scalar, which is a half. And as you can see, we're multiplying AB by 2. So I'm going to give you guys some vectors, and I want you to tell me if they are parallel. Now I'll make a little note here. 2 vectors can be parallel, but not collinear. So, guys, earlier, I don't like the silence thing, Electricity kind of bad today. But like, when I look at this logic, and forget about the fancy maths and thing, just look at this and tell me, can we see that these two are parallel for sure? Yeah.
Yes, sir.
Yes, sir.
Are they
Yes,
different
sir.
sizes? Are they different sizes?
Yes, sir.
Yes, sir.
Could everybody see that? Forget about the fancy maths. Just common sense. Just look at it.
Yes, sir.
The different sizes. Roughly speaking, I could say that AB is what a CD.
Uh-huh.
Half.
We could say that, right? We could see that. But to prove that, we need to refer to maths. But here we're saying, anytime you could write one in terms of the other one, it shows that they are parallel. Because parallel really means that they're going in the same direction. They're pointing in the same direction. Watch. Aren't both of them pointing in the same direction?
Yes,
Yes,
sir.
sir.
Are they seeing that, right? Yeah or no? If they don't understand something, when they talk to me, but just tell me. All right. So vector A to B is 2, 3. Vector C to D, I told you that it was 4, 6. So using this, I could say that AB is a half of CD, and I could prove that. Vice versa, I could say CD is 2 times AB, And I mean, you're seeing that, right? Because if this is AB, well, C to D would just be 2 times AB. Now, again, I'm not asking all any hard questions. Do both of these vectors start at the same point? Yes or no?
No.
Vector AB starts where? Somebody tell me. Where does AB start?
At A.
Okay, somebody else. Where does vector CD start? Somebody else answer. Where does vector CD start? So I'm talking about this vector over here, CD. Where does that start?
At C.
It starts at C. They both start at different points. So they have no points in common, so they're just parallel. Does everybody understand that these two vectors are just parallel? That is the only thing they have in common, that they're parallel. Yeah or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So I'm little trivia, right? Little trivia. Trivia. Are these two vectors parallel? Let me look at question one. Let me just say I have vector TV. Vector TV, I'm telling you I'm telling you is 4, 9. And then I'm telling you that vector LN is 3, 1. Would you guys say that these two vectors are parallel just by looking at the numbers? Yes or no?
No.
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 Can you tell me why that's not legal?
Because a parallel vector is two vectors are only parallel if one is written in of a scalar factor of the first one. So therefore, if LM was 8 and 18,
Okay, Joshua cooking today, boy. Joshua, you're cooking today, boy.
and
Hey, big up
that would
Joshua.
then would have been a parallel vector.
Joshua, you're bad, you're bad, you're bad. All right. These two vectors are illegal. That's right, proper thing, right? Okay. Could wait, just before I move on, is there anybody in class here that does not understand why these two are not parallel? Let me do a roll call quickly. Akira, you're good?
Yes, sir.
Alexia, you're good or not? You're not good.
Yes, sir.
All right. So Alexia, I have a question for you, right? I didn't know.
Yeah.
I didn't know. Let this guy escape, man. Pass your name. I'm calling all you. All right. Okay. Alexia, would you say that these two vectors are parallel?
Yeah. Wait, just now. -2. No.
Wait. So, like, how much of you all think that if I multiply this by 2, I'll get 48? Raise your hand.
Me.
Only 4.
Yes, sir.
Yes, sir.
They say yes, but that's wrong. I just catch all in 4K. I can't really see all your butts. That's wrong.
Some people, not me.
I see you keep your hand down. That's good. Only just because I tell all you, just because I raise my hand, that don't mean it's the right thing. It could be opposite day, right? All you, all you have a brain of all your own. All you don't, you gotta use that, like guys. I don't always be saying the right thing. I don't say the wrong thing on purpose, but like, I need a little think. Let me check it out, Alexia. So Alexia, when you looked at this on this, right? It was tempted to say the parallel length.
Yeah.
Because if you multiply this by 2, it kind of looking like you'll get 48.
But after I had a negative sign, so you'll get -4.
Again, negative 48. People in the class, is this the same thing as this?
No.
No, sir.
So was it legal for me to say that these two vectors are parallel?
No.
Sir.
They look parallel, you know. They look parallel, but they're not. But aren't. And let me show you why, right? Check this out. Some people might be tempted to say 2AB is equal to CD. But if you go to say this, you're going to multiply 2 by negative 2, 4. And where you saying now before it? Where's 2 by negative 2? Somebody tell me, where's 2 by negative 2?
Negative 4.
4.
2 by 4 is?
8.
Right. So, look at this. Again, no big fancy maths or anything. Only just using all your eyes here. Check this out, right? Check this out. Okay, the 8 and the 8 is the same, right? But like, you know that meme of the monkey? Looking like, you know what I'm talking about? Like, I don't know if you know what I'm talking about, but like, is minus 4 and 4 the same thing?
No.
As a, why,
No.
why are they so quiet for? Let me ask some people in class. Sky is minus 4 and 4 the same thing.
No, sir.
Jezara is minus 4 and 4 the same number. Nah, there's not the same number. So you know, this is not legal. This is not legal, guys. No, this is not legal. Right? So wrong. What about this one? What about OM? OM is going to be minus 1, 7. And then I have OL. And that is going to be 1 minus 7. Are these two parallel? Yes or no?
No.
Okay, guys. It's not a hive mind kind of thing here. It's not like Stranger Things. I want you to use all your own brains.
Yes, it is. It is parallel.
Okay. I have one yes, I have one no. Let me hear from the rest of you all. Things ain't interesting, boy. Things ain't interesting. I feel hyper today, but what was say? What was say? Feeling hyper today. Low key, low key. Um, I want to hear an answer from more people. We're too quiet. All right, let me ask Jelani. Jelani, are those two vectors parallel?
So yeah,
Okay, what make you say yeah?
um, because when you multiply, when you multiply so honestly, I don't know. I just say yeah.
Wait, boy. No, that's not what we want to know. That's not
So
what
I
we...
just look at it, but I just say, yeah, probably it is.
Joshua, try to abstain from drawing on your screen so much. Right?
So I wasn't here for the beginning of the class, so I don't know. So
All
I
right.
kind of
To show that two vectors are parallel, you need to be able to write one in terms of the other one by multiplying the other one by something. Right? So if I could say AB is a half of this one, they're parallel. If I could say that CD is 2 times this one, they're parallel. So is it
yeah.
possible? Is it possible for me to write OM as some number multiplied a sum multiple of OL? Is it legal for me to do that? Is it possible? Is it?
No.
All right. So minus 1, 7 over here. And we have 1 minus 7. People in class, is there anything I can multiply 1 minus 7 by to make it minus 1, 7?
Negative 1.
Negative 1. That's the answer.
Oh, okay.
So are they parallel?
Yeah.
Yeah, they are parallel.
Yes.
Excellent job. They are parallel. They would be parallel, but just going in opposite directions. If you understand what I'm saying. Maybe I should graph it out to show you what I mean by that. So
So
anytime you
one
see,
way, so one way, so.
exactly, anytime you see O, that means it's starting from the origin. So if I see negative 1, 7, let me show you what happening, right? It means I have to go one to the left. So there. And then I would have to go 7 up because this number here is positive. So I have to go 7 up. And that would be point M. So this would be -1 and this would be 7. Everybody understand now?
Yeah.
Okay.
Yes, sir.
And then O to L. O to L. This is O. We go in one here and then 7 down. It kind of looks like, okay, well, these two vectors would actually be collinear and parallel. Yeah, these two vectors are actually collinear and parallel, but you can see what I mean. Watch, both of them on the same line. They're on the same line, right? They're on the same line. So I tried to trick you guys, but yeah, these are parallel. Some of you all might be confused by that. How much of you all are confused by that? When you get the idea that once you can multiply something by another number to get back the same thing, it is parallel. Let me know if you all catch that. Once I could write one vector in terms of the other one as a scalar multiple, they're parallel. Let me know if you get the idea. If not, talk to me.
Yes, sir, I did catch that.
Well, let me look at a simpler example now. Let me look at a simpler example. So Regina, I want you to look at these two vectors, right? Let me just say I have OA, and let me just say vector OA is 3, 7. And let me just say I had vector OB. Vector OB is equal to tell me Regina, are these two vectors parallel?
No, sir.
Okay, does anybody in class think they're parallel? Christian,
Yes, sir.
Yes, sir.
Christian, talk to me. You think that these two vectors parallel? Christian, look Mira here, boy. Mira, Christian or Mira, one all here. Tell me, these two vectors parallel or not?
Yes, sir. No, sir. Wait, yeah?
Okay, so Christian, is it possible for me to write um is it possible for me
I
to
could
write
answer.
what say that again?
I could answer. Because you
Um
asked me if it parallel or not now, so I want to tell you.
you want to tell me, yeah. All right.
Yeah.
Christian, is it possible for me to write vector OB as some number multiplied by vector OA? That's my question. So we know that vector OB is 2149. Is there a number I could multiply OA by? Remember, OA is 37. Is there a number I can multiply 37 by to get 2149?
Yes, sir.
What number?
So 3 by 7 and 7 by
Yes,
7.
sir.
Right, so I could say OB is 7 times OA, which means they are parallel. Are you understand now? And
Yes,
in
sir.
addition to being parallel, they will also be collinear because both of them start at point O. But I'll talk about collinearity just now. Just now. Alternatively, I could have said that vector O to A is what of OB. Let me see how smart it is.
Seven,
Alternative. Camera Gary?
7 times.
Nah. I can't say OA is 7 times OB. Remember, OA is 37 and vector OB is 2149. If I multiply 2149 by 7, am I going to get back 37?
No, sir.
Nah. Everything, guys. OA would be what of OB?
Wanted.
Somebody said 1/3. Nah, it wouldn't be 1/3. Maybe I'll give all a hint, right? AB is a half of CD. Then I said CD is 2 times AB. Maybe this might be a hint. Okay, think now. So I'm telling you that OB is 7 times OA. Do you know what OA would be in terms of OB? Okay, maybe if I write down the vectors, you'll see what I'm talking about. So vector O to A is 3, 7, okay, and vector O to B is 21, 49. Is there anything I could do with 21, 49 to get back 3, 7?
Divide by 7.
Okay, now we want to write it as a multiple. So tell me, dividing by 7 is the same as multiplying by what? I want somebody to tell me that. Dividing by 7 is the same thing as multiplying by?
Multiply by 7.
Nah. So by that logic, Joshua, are you saying, check this, right? It's a limit at 9, wait, it's a limit at 14 divided by 7 is the same thing as 14 multiplied by 7? That's what you're telling me.
No.
Nah, that doesn't make sense. Okay, let me ask you a simple question, right?
So 3.
Nah, not 3.
3.5.
Okay, here it says, if I multiply 3.5 by 21, am I going to get back 3? Think about it, guys. I multiply 3.5 by 21. Am I going to get back 3?
No.
Okay, so look at a simple question, right? 4 divided by 2 is the same thing as 4 multiplied by what?
So is it 1/7?
It's 1 over 7. It's 1 over 7. And the answer to this question I have on the screen will be 4 by a half. So if I am dividing by 7, it's the same thing as multiplying by 1 over 7. Let me show you what I'm talking about. Could somebody tell me what 1 over 7 by 21 would give me?
3.
7 into 7 is 1. 7 into 21 is 3. 1 by 3 is 3. Is there anybody else in class that could tell me what 1 over 7 by 49 will give me?
7.
Right, 7 into 7 is 1. And 7 into 49 is 7. 1 by 7 is 7. Yeah. So in other words, you would say that OA is 1/7 of OB. So yeah, they are parallel. Does everybody follow?
Yes, sir.
Okay, let me do a little checklist. Akira, do you understand?
Yes, sir.
Alexia, you understand?
Yes, sir.
Ariel, do you understand?
Yes, sir.
Gary, what about you?
Yes, sir.
I see Jelani raise his hand. Jelani, talk to me.
So we could do a couple of more questions so I make sure I understand it.
Sure, no problem.
Thanks.
Jazara, be honest with me, right, Jazara? You feeling cooked? Jazara,
Yes, I understand.
all right. Jazara,
Yes, I
right?
understand.
I want you to stay unmuted, right? Quick trivia. Right? OC minus 1, 9. Vector OD minus 3. Tell me, right, Jazara, would these two vectors be parallel?
Yes, sir.
You are correct, Jazara. So, Jazara, tell me, how could I write that? So I could say one is equal to what times the other one? What could I say?
So 3.
Now, be able to tell me, so like, You gotta tell me a vector OC is equal to 3 times what? You gotta tell me the specifics.
Also, so wait a minute.
All right, check this out, right?
No.
Check this out. So over here, we said that OB was 7 times OA. You see what I'm talking about?
Yes.
Okay. So over here, what relationship could we form with OC and OD? Talk to me,
Yes,
Jazara.
sir. Equal to 3 of OD. So OC equal to 3 of OD.
All right, now that wouldn't quite be correct, and let me show you why. So we know that OC is minus 1/9,
Yeah.
and we know that OD is minus 327. Now, according to what you tell me here, right? If I multiply 3 by minus 3, I suppose I get minus 1. Would I get minus 1?
Also,
So
so
the
1/3.
1/3, if you want to write it like this, 1/3 is the correct move to make. Correct. So you could say OC is 1/3 of OD, because a third by -3 gives me -1. A third of 27 gives me 9. Nice. Now, Jazara, is that the only way I could have written one vector as a scalar multiple of the other one? Or was there another way I could write these two? Tell me, Jazara, is there another way I could write these two vectors, relating them to each other? Okay, so if we start off with OD, OD would equal to how much times OC? Talk to me. So we know OD is minus 327, and we know that OC is minus 19. So what would I need to multiply minus 19 to get back minus 327? All right, so Jazara, what would you need to multiply 9 by to get back 27?
So 3.
Right? And what would you multiply minus 1 by to get back minus 3?
3.
Right? So another way to write this, you could say that OD is 3 times OC. So either one of these are acceptable. Let me know if you understand that.
Yes, I understand.
Nice. Jelani, you fully understand that?
Yes, sir.
Okay, let me do
Ready
a,
for some past papers?
all right. There is no rush, we still have to do collinear, right?
Oh, all right.
Joshua, let me know if you understand.
Understand.
All right, nice. Christian, do you understand?
Yes, sir.
All right, nice. Mira, do you understand?
Yeah, sir.
Yes, sure, Mira.
Yeah.
All right, Nikolai, my son, do you understand?
Yes, sir.
All right, nice. Regina, how about you?
Yes, sir.
Okay, cool. Ria, talk to me. Let me know if you understand this.
Yes, sir.
Are you sure? You sure?
Yes, sir.
All right, we will get a question just now to make sure you understand it. Romano, you're good?
Yes, good.
All right. I find like Samir, he know what he doing. Sky, you good?
Yes, sir.
Okay, cool. So everybody now should be able to prove that two vectors are parallel. Obviously, in the questions, it's going to be a bit more complicated, but it's the same kind of process. Let's look at collinear vectors now. So collinear vectors are vectors that are parallel. So number one, they must be parallel. So I need to be able to write one vector as a scalar multiple of the other. So you need to say like, right, so if it parallel, one vector will be equal to the scalar multiple of another. Cool. And the other thing, if we're talking about collinear vectors, they must have a point in common, which would show that they're on the same line. So again, collinear vectors, guys, it's so uncomplicated, you know. Trust me, it does. But all it means is I have two vectors on the same line, like the line on top of each other, right? On the same line. Cool. So let me give you some examples. I check this out. Check this out. Um, could anybody just quickly read this off and tell me what is vector AD? Could somebody just quickly read it off and tell me what vector AD is by chance?
1, 6.
1, 6? No, wouldn't be 1, 6. What what you are describing to me would be for a position vector. A position vector starts at the origin. This vector starts at A. So from A, you would have to move 2 spaces to the right, and then you would have to move 3 spaces up. So that vector is really what?
2, 5.
No, that vector is 2, 3. That's what it is.
Wait, but I can't see that whiteboard. Oh yeah, I can even see properly. I thought it was 5. Oh shit, my bad.
Or language, yeah? We're not using them kind of words in class,
Sorry, sir.
right? So watch this. So this, the proper name for this is a displacement vector. Any vector that does not start from the origin is a displacement vector. But I think everybody could see that to go from A to D, you have to move 2 to the right and how much up?
3.
Okay, cool. So vector A to D is equal to 2, 3. So guys, would I say that AD is a position vector, or would I say it's a displacement vector? Would I say it's a position vector or a displacement vector?
Displacement.
Exactly. Look at this, right? Does this start at the origin? And you'll probably be saying, so well, where's the origin? This is the origin over here, 0, 0. Does this vector start at the origin? Yeah or no? Does it start at the origin?
No, sir.
No, it doesn't. Okay, let me give you guys another vector. And I want you to tell me if these vectors are collinear or just parallel. Somebody answer. Would these vectors be collinear or would they just be parallel?
Parallel.
I'm waiting for somebody else to answer. Ria, would you say that these two vectors, remember, collinear means that they're on the same line, right? So Ria, would you say that those two vectors, A to D and O to B, would you say that those two are just parallel, or would you say they are parallel and collinear?
Parallel.
Right. Do they share a common point? Okay.
No.
It's all in a little confused. Tell me, right, Ria, where does this vector start and end?
It starts at the origin
So that's O and it ends at.
and it ends at B.
Okay, so that starts at O and ends at B. How about this vector over here?
Starts at A and ends at D.
Do they have a point in common?
No.
No. You're saying now unsure, but look at it for yourself. This one starting at O, going to B. This one starting at A, going to D. They don't have any points in common. So
Mhm.
these would just be parallel. These are not collinear. Let me switch
Okay.
it up a bit. Okay, would I say that vector O to C and O to B are collinear?
Yeah.
Could somebody tell me why I would say that this vector and this vector are collinear?
So because point C and B lies on the same line.
But how will we show that mathematically? How I showing that mathematically? How I showing that? That's the question. How I showing that mathematically? So here what, right? Let me show you. No, I'll show you. First of all, both of these vectors are what kind of vectors? What's the name for these kind of vectors? Displacement or position vectors?
Position vectors.
Because both of them start at the somebody other than Jill.
Origin.
Both of them start at the origin. Great. Happy that we understand that. Now, quickly, could somebody just tell me what vector O to C is? By reading off that. So how would I go from O to C? How would I go from O to C? So I started at O. How would I go from O to C?
2 to the right and 3 up.
Right. So that'll just be 2, 3. Agreed? Okay, next
Yeah.
vector we have is O to B. O to B would be what?
5, 6.
4, 6.
4, 6.
Oh, I went past the. Okay.
Yeah. Yeah. But that's okay. First things first. Are these vectors parallel? And if so, could you tell me why they are parallel?
So because you could multiply it by 2,
Why can multiply by 2? You gotta be specific.
you can multiply OC by 2 to get back OB.
Let me know if all you agree with that.
Yes, sir.
Yes, sir.
Yes.
Does everybody in class see that if you multiply OC by 2, you're gonna get back OB?
Yes, sir.
Yes, sir.
So you know what we could write? We could confidently say that OC is equal to how much times? Well, if you're writing like this, you'll have to write it as a fraction. But if you wanted to write it like this, you can say that O to B is what? we could say that O to B, wait, what's it? We could say that O to B is how much times OC?
Keep going.
And can you prove this to them? Can you show this? Yes or no? Could I show this to them?
Yes, sir.
I could. O to B is 4, 6. We know that. Vector O to C is 2, 3. Will it work out? Yes or no? Will it work out?
Yes, sir.
2 by 2 is 4, 2 by 3 is 6. Great. So this means that OB and OC are parallel. The next thing we're looking for is a point in common. That's the next thing we're looking for. The very next thing we're looking for. The next thing we're looking for is a point in common. Is there a point in common between O to B and O to C? Christian, let me know if you're there.
Yes, sir.
Christian, again, forget about fancy maths and things. This is just pure logic at this point. So, Christian, talk to me. That vector carrying you from where to where?
From O to C, sir.
O to C. And this vector carrying you from where to where?
From O to B.
Both of them, do both of them start at the same point?
Yes, sir.
So do they share points in common?
Yes, sir. They share 0.
Right, they share point O. So OB and OC are parallel, right? So this is the statement you're going to write. Since OB and OC are parallel and share a point in common, O, they are collinear. All right. Let me know if you understand that.
So I don't understand.
Wait.
Yes, I understand.
All right. So since I feel like I already said it bad. Since O to B and O to C are parallel and share a point in common, O, they are collinear. All right. So Jelani, you don't understand, right?
No, sir.
All right. So Jelani, first things first, collinear. And both of them had to be pointing in the same direction.
Yeah.
But and they could be in different places and pointing to the same direction.
Yeah. But not like,
Oh.
I mean, like not from the origin, like the starting from anywhere.
Yeah, watch. Okay, look at this example, right? These were parallel vectors. Would you say that these two are collinear?
No.
No, because are they on the same line? Are these vectors
No.
on top of each other?
No, sir.
No. Because both of them start at two different points and both of them end at two different points. Seeing that, right?
Yep. Yep.
Do they have a point in common?
No.
No. However, I have a question, right? If instead of AB starting from A, okay, you see this vector over here?
Yeah.
I would just say it didn't start at A, right? It didn't start at A. But the vector is 2, 3, right? So this is the vector over here, this line over here. Let me just say it started at C.
Mm-hmm.
Would
Yep.
would it be collinear now?
Yes.
Okay. Okay. If you understand that, then you should understand this. Check this out.
All right.
Vector O to B, right? Vector O to B.
Yep.
What that vector starts from where?
The origin.
And goes to?
B.
Okay. This vector over here now.
Start from the origin and go to C.
So do both of them start from a common point?
Yes, the origin.
Doesn't that prove that they are collinear? Does not show that they are on
Oh.
the same line?
Yeah, I understand.
Because think about it. If OC did okay, if this vector wasn't starting at the origin, it could have started over here, but would it be collinear?
No.
No, but because it's starting specifically at the origin, which is a common point with OB, you can see that they are collinear, right?
Yes, sir.
All right, we cooking?
Yes.
All right,
sir.
there's another way to do that question, you know. I'm gonna show you the other way to do the question. So, if this question does come in the exam, they might be like, prove that points O, B, and C are collinear. So this is how the question would come in the exam. They would be like, prove that points O, B, and C are collinear. Now, if two vectors are collinear, it means that they are parallel, number one. So scalar multiple, that's where that come into play. And they must have a point in common. So this is how they would ask us in the exam. And if you put on this work in, you'll get full marks. But there's another way to do the question. Regina, you there? Regina, let me know if you're there. Can I hear Regina so much? Gary, let me know if you're there. Gary Griffith. You there?
Yes, sir.
All right. So Gary, check this out. This is vector O to B, right?
Yes, sir.
Okay, and this is vector where to where?
There's the midpoint.
Wait, eh?
What to say?
Okay. This vector is where to where? So here what, guys? I just want a little think about a vector as a line taking you from one point to the other point. Don't think like that is all you have to understand. Because that's what it is. So this vector taking you from where to where?
They take me from O to B,
Okay, O to B. This vector over here taking you from where to where?
C to B.
Right. I have a question. Doesn't okay, if I had vector CB and I had vector OB, what is the common point that they have? What is the common point that they share?
B.
Everybody could see that, right? Let me make sure everybody could see that. Samir, over here I have vector O to B. You agree?
Yes, sir.
And over here I have vector what to what?
C to B.
Do both of them share a common point?
Yeah.
So would they be collinear?
Yeah.
Yeah. Hear this. Once it have a common point, it collinear, you know. That is once it have a point in common. It's that simple. That simple. Okay, guys. We know that this is vector O to C. This vector will be what? Just remind me again. This one over here.
C to B.
Okay, would vector O to C and C to B be collinear? Guys? Would
Yes.
vector O to C and C to B be collinear?
Yes, sir.
Yeah, because
No.
do both of them share a common point?
Yes, sir.
What point do both of them share?
C.
Both of them share C. And as a matter of fact, if you work this out, you'll see that OC and CB is the same vector, which also means that they are parallel. Because technically, if they're the same vector, and I could just say this one is equal to 1 times the other one, think about it. So yeah, there are multiple different ways you could go about showing this. But the point is, once it's a scalar multiple and they have a point in common, we smile and we Gucci. Everything's fine. So to prove that two vectors are collinear, and that means they're on the same line, and you must be able to write two vectors as scalar multiples. You need to be able to write one vector as a scalar multiple of the other. And that is this part over here. Hope you understand that. Next thing, we need to look at a common point. So do those two vectors have a point in common? If they don't, well, they could be parallel. But if they do, and they are parallel as well, they'll be collinear. So Jelani, do you understand the concept now?
Yes, sir.
Okay.
Ouch.
What was everybody else in class?
Yes, yes, sir.
Yes, sir.
Yes, sir.
All right.
Yes.
Let me incorporate shapes into this thing now. Let me incorporate shapes into this thing. What shape is that? What shape is that? Guys, we don't know which shapes too, you know. I can't be forgetting all the shapes. What shape is that?
Parallelogram.
Parallelogram.
Is a parallelogram, also called a quadrilateral. Cool.
Yep.
If this is vector A, then what would this vector here be?
E.
Yeah.
That would also be vector A. Because for a parallelogram, opposite sides are
Parallel.
exactly they're parallel. They're the same. Come on, guys, we have it. If this is vector B, what do you think this would be?
B.
B.
What do you think this would be? It would be B, right? It'd be B. All right. So I kind of building up that question you could get in the exam, right? So let me just label these points quickly. So I could call that O, A, B, C, and I could call this point D. Everybody with me so far?
Yes, sir.
Okay. So in one of the questions, they might ask you they might ask you how to go from okay. Let me make a valid question, right? Make a valid question quickly. I'm gonna think. All right, so they might tell you that they could tell you this is vector C or something so. Actually, let me just show you what will happen, right? So they would give you a parallelogram. They would give you a parallelogram, and they might give you a random point in the center. So they will say that's the midpoint. That's the midpoint. Cool. That's the midpoint. And then they might, in the end, they might be like, show that ODB are collinear. Now, when you look at this, right? When you look at this, could we see that they are collinear? Like, again, collinear just means that they're on the same line. Could we see that they are collinear?
Yes, sir.
Like, let me know. Could everybody in class see that O, D, and B lie on the same line? Let me know what
Yes,
you're
sir.
seeing now. Could we see that with our own eyes? Yeah or no?
Yes, sir.
Yes, sir.
Yeah.
Okay, cool. And so what you would have to do now, you would have to okay. We have points O, D, and B. What vectors could we pull out from that?
O to D and D to B.
O to B. That way it's in O to B and
So I say O to D and D to B.
O to D and D to B. Excellent. And so if I could prove that these two vectors are scalar multiples of each other, it means that those two are
Parallel.
parallel. Yes, parallel. And the
Right.
next thing we're looking for, do they have a point in common?
D.
Yeah, both of them have D in common. So it's that simple, you know. Once you could show that, it means that those points are collinear. That's that simple. So I think we can now start past paper questions. This is the thing that has give people the most problems. Uh, Let me go in the past. Let's see what happened in 2012. Okay, that's not the type of question I'm looking for. Maybe like 2014. He This is a nice question, but it's not the type of question I'm looking for. Because the more recent questions is like it's just geometry. Maybe I could check 2016. Uh Okay, not the type of question. But we could do this question because they say in part two show that they are parallel. So let me do this question quickly. Who I need a volunteer. Somebody volunteer fast.
Yes, sir.
All right, bet. So we have points A, B, and C. So point A has this coordinate, point B has this coordinate, point C has this coordinate. Do you understand that coordinates tell you the vector, the position vector?
Yep.
You sure you understand that?
Yes, sir.
Because and when you're putting down, and when you're plotting a point, you start at the origin, then you go to the right or left, and then you go up or you go down,
Yes, sir.
which would just be x comma y. So all
Yeah.
these points will tell you the position vector. M is the midpoint of the line segment AB. Cool. M is the midpoint of the
Yes, sir.
line segment AB. That's cool. So we might have to use the midpoint formula. Jelania, I believe you was asking about the midpoint formula, and
Yeah.
all right. Do you remember the midpoint formula?
Midpoint formula.
It is a
I
midpoint
think
formula.
I didn't. No, I didn't look at that one. I never saw that in the notes.
Right, all right. But I had another midpoint formula. Let me show you that quickly.
All
So
right.
the midpoint formula is just
Oh wait, never mind. Never mind. Okay, never mind. I know that.
all right. Well, I'll
That's
just
from coordinate geometry. Yeah.
yep.
All
Is
right.
x1 plus x2. So you're gonna
Yeah.
add the two x values, divide that by 2, and then you're gonna add the two y values and divide that by 2. And all of this is from
Yeah.
coordinate geometry.
Yes, sir.
Okay, raise your hand if you got confused when I said that these points over here would tell you the position vectors. Raise your hand if you got confused when I said that, because I think some people got confused. And it's okay if you're confused. You just had to tell me. You know what? I had trust issues. I don't trust all you. I feel like all you're confused and all you're not telling me. So we had to do something about that. Where are my graphs? Okay, here we go. People in class, when you're plotting a point, right? The first value is a what value?
X.
The first value is the x value. The second value is the
Y.
right. We know that, and everybody else we know that.
Yes,
Christian,
sir.
Christian, and we know that. Nicola, yes, we know that. Christian, and
Yes,
we
sir.
get that. So Christian, if I wanted to plot the point 4, 2, here what we would do, right? And I would go and I would look for 4 on the x-axis,
Yes, sir.
and then I would look for 2 on the y-axis. And
Yes, sir.
right, check that out, right? 4, then 2. Talk to me. Didn't you just put on a vector? Because you just went from where to where?
From 4 to 2.
No. All right, let me run that back one more time. So I want to plot point B, which is 4, 2. What's the first thing I'm going to do? Tell me, Christian. If it's 4, 2, what's the first thing I'm going to do?
Find the x-axis.
Well, I mean, the x-axis is over here. But what are we going to do next?
Oh, well, they're going on a plot the graph, sir.
Okay, but the graph already there. Yeah, let's tell me. What are going to do next? So my point is 4, 2. What are going to do next?
So you're going to look for 4 and then 2, sir.
Okay, let me think a little further than that. So, Christian, what you're really doing is, yeah, that's okay. You take a guess, Christian. Where do you think I'm starting from? Where do you think I'm starting from? And then go into 4.
So you're starting from 0, sir.
Exactly, I'm starting from 0, 0. Yeah? I'm starting from O. And then from O, you're going to where?
So 4, sir.
You're going to 4. And then from 4, you're going to
2.
So talk to me, and I'll call this B because the point was B. So long story short, Christian, we start from where? We start from where? Where we start from?
Start from 0, sir.
Start from O. And I eventually reach where?
You reach the 4.
Nah, I reach B. Remember, B was 4 too. So
Oh yeah.
I move 4 to the right, and then I move 2 up. So I eventually reach B.
Oh, yes, I understand.
So isn't that just a vector?
Yes, sir.
So guys, anytime I see a coordinate or a point, then the x and y value is just gonna tell you what the vector is. So if you see B 4, 2, then that means vector O to B is what? Christian, tell me. That just means vector O to B is what? Don't overthink it. It's real simple. It's literally in front of you. I promise.
4-2, sir.
That is all. That is it. That is it. I tell you, Christian, it's real easy, you know. Very simple. Christian, while you're at it, what do you think O to A is?
2-8, sir. No,
Minus.
negative 2-8,
It's
sir.
easy. So what I'm saying is, guys, I saying anytime you're given points or coordinates, the x and y value will literally tell you what the vector is. And I mean, CX, you tell it, they tell you x comma y. I mean, they tell you x, y. So I mean, it kind of make it a little straightforward. So, question, tell me, what would O to B be equal to? O to B. O to B is equal to what?
4-2, sir.
That is all. 4, 2. All right. Now, A to B is going to be a bit harder. But my question for you, right, Christian? If it's A to B, then you would have had to start from where? You would have to start from where?
From B, sir.
From B? Nah, you lost me there. You lost me there. Kind of sus. Read this for me. Read anything. Like, okay, I see Jelani. Jelani, raise your hand. I'll talk to you just now. But Christian, when you look at that and you read it, would you say starting from B, then going to A? Would you read it like that? How would you read that?
Starting from A, then going to B, sir.
That's why I'm saying A to B. Wouldn't start at B. So you're starting from where?
From from A
Starting from A. And then somehow I had to end up at where? Oh, what is my
at
final?
B
Fine, at B. Okay. And I know that all of these vectors starting from where?
from 0-0.
From the origin. Just say O. All right.
From O,
So
yeah.
I could say A to O and then O to where?
O to B?
Yeah. Yeah. That's it. That's it. Simple, right?
Yes, sir.
Yeah, it's simple. And I need to explain something. Anytime you switch directions, you change the signs. So Jelani, talk to me. Let me know if you're confused by anything.
So I just wanted to ask, is it supposed to be negative OE plus OB? I just wanted to ask that. Let's see, I was confused.
Okay. That's a good thing that I mentioned that. Guys, could somebody tell me in class what AO is? What is A to O? Somebody tell me that. What is A to O? A to O is the same thing as what?
O to
O,
Now, negative OA.
A. Alright, because you're going backward.
They're going backwards. So Jelani, I'm going to show you something and it will make real sense, you know. I promise it will make real sense.
All right, so let me see.
All right. So Jelani, if I want to put on the vector OB, I starting from the origin, then I'm doing what?
You're moving 4 spaces to the right and 2 up.
All right, so I'm moving 4 spaces to the right. So I'm starting from here, yeah? Oh,
Yeah.
and I'm going to move 4 to the right and I'm gonna move 2 up. And that's gonna take me from where to where?
Point B. Well, O to B.
All right. So let's look at how you moved. You moved 4 to the right and then 2 up, yeah?
Yes, sir.
I have a question, right? What if I wanted to go from B to O now? How about doing that?
You switch well, you just do the opposite. Well, you change your sign.
But let me think about
Well,
it.
negative.
Let me think about it logically, right? You're starting at B. You're always moving horizontally first.
Yes, sir.
Always moving horizontally. So, would you move to the left or to the right?
Left.
I'll move to the left. How much space is to the left?
4.
So that'll be -4. And how much space is down?
-2.
So, let me explain something. So, O to B was 4, 2, yeah?
Yes, sir.
And B to O was what?
4, 2.
No, what? B, how did we go
Wait,
from?
sorry.
How
Wait,
did we
-4, -2. Sorry, my bad.
-4, -2?
Yes,
So,
sir.
Jelani, by me switching directions, what happened to the 22?
You just change signs.
So, in other words, I could say that B to O is just what OB. What would I need to do with OB to get -4, -2?
Multiply by multiply by -1.
Yeah. And that is why I'm telling you that BO and -OB is the same thing.
Oh.
The next
Okay.
next time I was gonna write -OB.
Excuse me.
Yeah, Joshua?
May I use the washroom, please? Thank you.
Yeah, sure, use the washroom. You don't ask me. Yeah, but yeah. All right. So Jelani, anytime you're switching directions in vectors, you change the sign. So Jelani, vector B to O is the same thing as just -OB. You understand?
Yes, sir.
Does everybody understand that B to O, so B to O is in the opposite direction to O to B? All you know that? Are you seeing that? Okay. All right, so this is O to B, right? And this would be B to O. Are they going in the same direction? Yes or no? Would they be going in the same direction?
No.
Opposite.
They're going in opposite directions. So anytime you're going in the opposite directions, you change the sign. And so if to go from O to B was +4, +2, then to go from B to O, it'll be -4, -2. And I hope all they could see that that is just -4, 2. That's just -OB. That's all it is. That's all it is. All it is. So Jelani, in the next line, I'm going to say instead of writing A to O, what do you think I'm gonna write?
OA.
Exactly. Because the A to O will be going in the opposite direction to what?
AO.
Nah.
Oh, OA, sorry.
OA. Hence I wrote it as -OA.
Okay, sir.
Okay, so Christian. Remind me, Christian, what is vector OA?
So vector OA is 4, 2.
Nah.
Oh, OA, my bad, sir, is -2, 8.
-2, 8, right? So I'm gonna put -2, 8 over here. And vector OB is what?
OB is 4, 2.
So if you change the signs for -2 and 8, you're gonna wound up with 2 -8 ends.
Yes, sir.
All right, and if you add the horizontal components, 2 + 4 is?
+4 is 6, sir.
And -8 + 2 is?
It's -6.
Now let me show you a shorter way to do that, right? And this is how I would do it in the exam. So we don't know that we starting from A, we had to go to a middle point, and then from the middle point, you can reach a final destination. Yeah?
Yes, sir.
Now, Christian, A to O is the opposite direction to what? That's in the opposite direction to what?
It's the opposite direction of O to A.
Exactly. And guys, anytime we're going in the opposing direction, we do the signs.
Change it.
You change the signs. So Christian, hence we know that vector, We know that OA is minus 2 8th.
Yes, sir.
So AO would be what automatically?
2 -8.
Exactly. 2 -8. OB is 4 2. Easy peasy, lemon squeezy. That's what he's saying. Let's go. 2 plus 4 is 6. Minus 8 plus 2 is -6. Bam. Anytime you see
So,
any opposite
so I did
direction,
it.
you change your sign.
So
Yes,
I
you
did
are.
it the second way. With
But,
the second one. Yeah, that one.
but you was telling me about
Wait,
negative OA though.
wait, I know both. I did the both.
Okay, well, both is the same thing, you know. Both of
Yeah,
them.
I know.
I just leaving out this line because here I know, right? Here I know. AO going in the opposite direction to what?
Oh, eh?
Exactly. Anytime you go in the opposite direction, you change signs. That's it. Yeah.
Yes, sir.
Bet. So everybody okay with this?
Yes, sir.
Yes, sir.
All right. Gianna, let me know if you're there.
Sir, it's paper 2026, January.
Okay, I will do that. Let me just finish with this question, right? And you go help me with that question. We're gonna look at it together. Let me know if you're okay with that.
Yes, sir.
All right. Guys, are we cooking?
Yes, sir. We are.
Nice, nice. So on to the hard part of this question. O to M. Now, when students reach there, they're gonna be scratching their heads and they're gonna leave it out. Because they're gonna be like, oh, M? Where that come from? I never see M anywhere. And you'd be wrong. Remind me what M is. Remind me what M is.
The midpoint.
Midpoint, sir.
Right, is the midpoint of
AB.
exactly. M is the midpoint of the line segment AB. Question, do we know what AB is?
Yes.
Yeah.
What is AB?
6 negative.
6 -6. Everybody okay with that?
Yes, sir.
Sir.
So maybe I should graph this thing out and you go understand what happened in here. Because I feel like some people might be a bit confused. Low key. Alright, so I'm gonna put on A, O to A. I'm gonna put on that first. We know that vector O to A is just -2 8. -2 8. So if I want to go from O to A, I need to go 2 to the left and then 8 down. I mean, what's in 8 up? 2 to the left and 8 up. So that'll be right here. So what would I call that point over there? Somebody just tell me what would I call that point over there?
A.
I call that point A. Great. And then we have B. B is 4,2. So that's going to be 4 to the right and then 2 up. And then what is C? What is C? What is C?
0.
Okay, remember
Yes, sir.
the X value tells you how you're going to move left or right. That's what it tells you. If it's
Yeah,
0,
I'm
am
moving.
I going to move left or right?
No, sir.
No. And then I see a 9. So I'm not moving left or right. So I'm staying at O. And then I see a 9. 9 telling me to go up or down.
Up.
Up.
Telling me to go up. Because we up right now. Right? Cool. And this will be O to C. It have anything I do here that was like utterly confusing?
No, sir.
No? Alright. And I could connect A to B?
Yes.
Yeah.
Because what they ask me to find? What did they ask me to find?
OM. Well, the midpoint.
Well, I'm talking about you're right, but we're looking at this. Looking at this
Oh.
for now. So A to B, right? If it's A to B, wouldn't I draw the arrow in this direction?
Yeah.
Yes.
And looking at the diagram for itself, and so you could see that if you want to go from A to B, you really had to go from O to A. And then you had to go from O to B. And so let's see in that.
Yes, sir.
Okay, cool. So I hope we understand that part over there. Let's look at the O to M part. So they're saying that M is the what? M is the what?
Midpoint.
Is the midpoint. The midpoint along the line segment AB. So this is the line segment AB. A line segment is just a piece of a line. Don't let it confuse you. Where's the midpoint there? Anybody can see the midpoint?
Yes, sir.
It'll be over here, and
yeah, half. Yeah.
that is all. That is all. So let's find the midpoint. How would I find the midpoint for that? Again, this is the midpoint formula, guys. This is the midpoint formula. How am I going to apply the midpoint formula here? Could anybody tell me what are the 2 points I'm going to use to find the midpoint to find the midpoint?
A and B.
Everybody, we want to find the midpoint between what 2 points?
A and B.
So doesn't it make sense for me to use A and B as my points?
Yes, sir.
Yeah, it makes sense. And so remind me, somebody remind me. Point A was what? What was point A?
-2, 8, sir.
Was it -2, 8? Yeah, it was -2, 8. I just read kind of stupid. Okay. Oliver, I heard you saying that engineers is cost plenty. Anybody ever hear that?
Yes, sir.
Like the stereotype is becoming real. Like when I'm a lab partner, she's never cursed. Since like I know her. But like today, I finally heard her crack. And it's like I find it happening to me too. Like I'm on the verge of, you know what I mean? Like on the verge, low key. Low key sometimes. But I will not resort to such vulgar language. You know what I mean? At least they would never hear me say those kind of things. But anyways, if I want to find the midpoint of line segment AB, I'm going to use point A. Point A is -2, 8. And then I'm going to use point B. Where's point B? Tell me fast. Where's point B?
O2.
O2.
sir.
Which one do you want to call the first point and which one you want to call the second point? It really don't matter. Really don't matter. But just tell me.
You just go with A and B. A is the first point and B is the second one.
But again, it don't matter, because you could add however and you get the same answer. So let me find the midpoint. M would be what? Tell me what to write.
-2, comma 4, sorry, over 2.
Wait, somebody else, tell me the other one. So we handle X there. Tell me why it go look like now.
8 plus 2 over 2.
What are we gonna get? Where's -2 plus 4?
2.
And 2 over 2 is 1. And 8 plus 2 is 10. 10 over 2 is?
5.
5.
Aha. So the midpoint is 1, 5. Everybody understand that?
Yes, sir.
Yes, sir.
Oh, let's see how crazy this is. Watch that. Like it low-key look like it's 1, 5, right?
Yeah.
Like low-key, that kind of crazy. And so like, wouldn't that be O to M?
Yup.
Yeah, it would. I'm gonna follow understand that.
Yes, sir.
Let me run that back one more time, just to make sure we locked in. They told me that M is the midpoint at the line segment AB. If it's the midpoint at the line segment AB, then I need to find the midpoint using what 2 points?
A and B.
A and B, because A and B are the endpoints. So I'm gonna add the x values, divide that by 2, add the y values, and divide that by 2. So the midpoint is gonna be 1, 5, which is in the middle of AB. And you don't have to do anything else. Because remember, what did I say about coordinates? I said that coordinates tell you the position vector. Did I not say that?
Yes, sir.
Yeah. Anytime you see points, they tell you the position
Yeah.
vector, unless specified otherwise. But if you see points, if you see a point, the point would have had to reach there by starting from the origin. Just think about it. If I have a point 1, 5, how I reach there? Talk to me, how I reach there? I would have had to start where first? Where would I have to start? I would start here first, and I would do what, Akira?
Then you will. Mhm.
You're overthinking it, you're overthinking it. 1, 5. What's the x value?
1,
So I move 1 to the
1 to the,
a positive number. If it's a positive number, what do I mean?
you move it to the right side.
1 to the right, what next?
And you move 5 upwards.
Right. So if that's the case, then O to M is just simply 1, 5. That's it.
Yes, sir.
That's it, real simple. Maths is best. Maths is simply peak.
Nah,
Now,
sir.
God disagree with that. Maths is the peak. Maths is the best. I'll low key kick you out. I joking. I wouldn't do that, but like maths is the best, man. Come on, man. Maths is the best. But I can agree that everybody
I
has a
think so.
difference. I feel like I could agree that everybody have different strengths and everybody will be drawn to different things for sure. So maths can't always be the best for everybody, but like I hope I can see how simple it is, low key. It don't have to be that hard. It don't have to be that hard. It don't have to be that hard. But sometimes it's be unnecessarily hard. I'm not
So
gonna.
you just make it simple.
I want you to make it simple for yourself in the exam. But okay, I'll accept the compliment. I'll accept the compliment. Thank you. Totally not blushing right now.
So we
Nah.
can see it, by the way.
Yo.
I can see my way, boy.
Yeah.
I gotta ship
So we
it.
can see it totally not blushing and thing. I just letting you know. Yeah.
Okay, wait, a poker face.
Yeah.
Yeah, so you're looking too it's not looking too good for you right now. Yeah.
I can do a
Nah,
poker face.
nah, sir, nah.
I can't do a poker.
0 to 10 on that poker face,
So
boy.
nah, just give up. Just go home at that point. Nah, sir, nah. Wrap it up. So wrap it up.
Put the fries in the bag. Put the fries in the bag and then yeah, boy. I
0 to 10 on that poker face.
way too chalant, dog. I way too chalant. I can't be nonchalant. It's crazy. Down. Fellas, chalant is low key the way, if you want to pull birds. But now it's only time to pull birds though. But like after, like when you're like stable and you're making money and like you're mentally stable and thing when you're older, like 20 something, you know what I mean? Yeah. I don't feel like nonchalant is the way. I feel like chalant is low-key the way. Genuinely. You gotta be yourself. Yeah, you gotta be yourself. All right, let's do this question quickly. Anybody want to volunteer for part two? Part two. Anybody? Anybody? Come on, guys. We know this. We know how to handle this question.
Me,
Okay.
sir.
All right, Nikolai. If two vectors are parallel, then I could write one of them as a what of the other one.
Repeat, sir.
If two vectors are parallel, I could write one of them as the what of the other. As a what?
Equal.
Say that again.
Oh. Equal. Oh.
You're missing something there. I need to be able to write one of them as a what of the other one. Starts with S.
Oh, scalar multiple.
Right. Scalar multiple. So, Nikolai, before we do anything, right? I want you to ask yourself, do we know what vector A to C is? Do we even have vector A to C yet?
No, sir.
Nah, so we had to find vector A to C, yeah? So like if I want to go from A to C, obviously that means I'm starting from where? I'm starting from where?
O to A.
I started at A and I go in and I had to end up at where? Where's my final destination?
C.
C. Now, all of these are position vectors. And so position vectors start from the origin. So the origin is going to serve as like a reference point. So I'd say A to where plus where to C.
A to O.
I'd say A to O and then from O it would go to C. So A to O, O to C. Now, Nikolai, A to O is the same thing as what other vector? Like, kind of. Is more or less the same thing as what other vector?
Scalar multiple of OB.
Nah. Vector AO is like the same thing as OA.
Oh.
However, they're going in the same direction or different directions. I should check this out, right? So like Loki, they're the same thing, but like one of them going in the what direction?
Opposite.
Anytime we go in the opposite direction, we're gonna do the signs.
You can change it.
Right. So AO. All right. So I way to look back at OA. OA was -2, 8. What do you think AO would be?
Positive 2, -8.
+2, -8. Bam. OC now. Let's look at OC. Well, they gave us any question, right? OC was what?
0, 9.
0, 9. So when you add that, what are you gonna get?
Um, 2, 1.
2, 1. Wake up yourself. So we finally have AC. Do I know what vector O to B is?
Yes, sir.
What's vector O to B?
4, 2.
People in the class, are they seen it one time? So they tell them that vector O to C. They tell them, what was I saying? They tell them that vector O to B, right? O to B is 4, 2. Are they seeing the link between AC and OB one time? I'm wondering if are they seen it.
Yes, sir.
Romano isn't the only one here. Christian, ladies, Sky, my favorite child, supposedly. But my favorite child I'm talking to, so I can't really.
Apparently.
I don't know if that's your favorite child, because I feel like the favorite child will be talking more, low key, right? Low feel.
Sir.
Say that again.
So I say I eat them, but trying to pay attention.
You gotta be eating maths. You gotta be eating in the maths. You know what I mean?
All right.
The paper.
Yeah. No, nah. Don't be moving like I go to the exam.
So don't worry, I'm not like Romero.
You just don't say Romero.
Oh God.
Hey.
You know, it have one of my friends in school name is Romero, and everybody just call me Romero and him Romano. And we just get real vexed.
Your name is Ramona.
I'll leave it. Not forgot.
Yeah, boy. Ramona. You know how much time I mix up your name the first time we meet? Boy,
Yeah.
boy, that was embarrassing, boy. That was embarrassing, Loki. Kinda embarrassing. But Nicola, you see any link between AC and OB?
Yes, sir.
All right, to talk to man. It looking like how are these vectors related?
2.
Yeah, you had to write a statement for me, right? So you had to say like this vector is equal to what times this vector.
OB is equal to 2 times AC.
Let me know if you're seeing now.
Yes, sir.
And how could I show this true? How could I verify that? Is there any way I could verify that?
Substitute.
Yeah. OB is 4, 2. AC is 2, 1. What is 2 by 2?
4.
What is 2 by 1?
2.
2.
Right. And the wheel keeps spinning. Big up. So with these kind of questions, I advise you to write a little statement at the end. So it could be like, since OB is a scalar multiple of AC, um, they are parallel. And if you want to be like real bad, like real, okay, like if you want to be goated, you could also say, wait oh yeah, yeah, hello, you good?
Bring them some food for you.
No, teaching a class now. You wanna wish each other good luck?
When it's exams.
When exams is in 33 days.
33 days, okay.
Yeah.
That's children, kids. Hope you all do better. Should I bring them some food for you and leave it downstairs?
Should I bring out some food for them? Them looking hungry, and them talking much in class.
Oh,
Yeah.
Yeah, real hungry.
okay.
All right.
Yes, I agree too.
They want help. They
Yeah,
want.
we're here. We could eat.
Yeah, you feeling for some press food or?
I will never ever say no to press food. If I ever say no to press food, it is not me. I've been cloned.
That makes
Yeah,
sense.
I've been cloned.
Now we know how to distinguish between real and a clone. It's good
Yeah,
information.
so right, good.
Yeah, you can do that. Just I'm trying to roti.
It has no chana roti.
Oh,
They
I'm
make rice and noodles and soya and
cute.
some sauce and macaroni pie.
All right, well I'll take rice and soya.
Okay.
Yeah.
Now this game, I'm real hungry, you know.
Are they like Loki, like the behind the scenes and thing? I'm gonna for you
Sir,
like
sorry, sir.
Yeah.
Nicola, you good?
No, but sir, sorry, sir.
Yeah, soya.
Yeah, but sir, you have a whole spread and you choose to eat soya and rice by sir,
It okay, it's our prayers, number one, so there no meat. And like
Well, yeah, we figure.
right. And it's like I don't want to have too much carbs. Genuinely.
Okay, but you choose willingly to eat soya and rice?
Soya, this is good, boy. What do you mean?
Now say I lost my heart there.
Hey boy. I like soya.
I
I like soya. I don't know.
Wait, you lost your favorite childhood.
No
Oh no,
sky.
I wasn't. I wasn't the favorite child. I was I was. Why is it the forgotten child?
Naria, you
The
never
forgotten.
forgotten. You never forgotten.
I
But
was the
here is it.
forgotten child. But yeah.
But why would you say that though?
Joshua is all jokes, man. It's all jokes. Not to be taken seriously.
It's not serious, Joshua. It's
Oh,
alright. So can't forget me.
Yeah, I will never forget Ria. But if they want to be extra bad, like a real, like, okay, if they want to go the extra mile, you could also tell them that it's not collinear. Could anybody tell me why these vectors not collinear? Anybody?
They don't lie on the same point. Line. Sorry.
Because they don't equal common.
I mean, you're not wrong, eh, Jelani, but I want to hit phrase a bit better. Christian, what are you saying?
They don't share the same point.
Because they don't have any points in common, sir.
Yeah, that's it. If you notice, like, okay, what? A to C, all right, and then O to B. Nah. They don't have a point in common. And let me show you something real quick. So I know that, okay, let me put on A to C, right? A to C is 2, 1. Now, watch this carefully. When I'm putting down AC, am I going to start from the origin or am I going to start from A? If it is AC, am I going to start from O or am I going to start from E? It's a highly logical question. Alia, talk to me, Ria. If I have AC is equal to 2, 1, am I going to start from O or am I going to start from E? Okay, Ria, think. What does this vector say?
AC.
Okay. Come in terms of like directions, like I'm going from where to where.
We're going from A to C.
So where I starting from?
A.
Will I be starting from O?
No.
No, that's the answer. We're not starting
Oh,
from O.
I thought it was a trick question because I thought that
I
was like obvious.
I don't ask for a question. Most of the time it's just highly logical questions. Right?
Okay.
All right. So if I wanna put on wait, oh my god. Don't worry, we're gonna do the 2026 question just now. If I wanna put on AC, that's just watch this, right? So that'll just be 2 and then 2 1 should be AC is 2 1. Watch. Aren't you guys like low-key mind blown? So I said that AC is equal to it was 2 1 ends, and let's say that. And that's what I see, right? And it's like we starting from A, and then how we moving? How we moving next? How are we gonna move next? I'm waiting for somebody to tell me. It's 2 1. So I starting from A and I'm moving 2 to the left, 2 to the right, 2 to the up, 2 to the down. What moving?
2 to the right and 1 up.
And where would I end up at? Are you overthinking this bad boy? What is vector?
0.
What does vector just tell you? Where does the vector take you?
From the
From A
start.
to C.
From A to C. So we end up from point A to point
C.
Right. So this vector over here would be A to C. You see this? This is vector A to C. That's A to C there. A to C. Can everybody in class see that A to C looks parallel to O to B?
Yes, sir.
But do they have a point in common?
No.
Nah, they don't have a point in common. One starting from A and then at C. Yeah, that one starting at O and ending at B. They don't have a point in common. Never. Right? Okay. So we're done with this question. That's it. So if you wanted, you could add in this extra part to just show them that you better than that you CXC already for you. And you could always just say also, um, they are not collinear, as they do not share a point in common.
999 Aura.
Yep.
It's the brain rot for me.
The brain rot. What brain rot?
So that is brain rot.
This is brain rot?
No, not that. The
Oh,
999 or what Romano just said.
nah, that's like an old one, like with because I know
Oh,
the
that's brain rots.
I wouldn't say it's that
That's
brain rot.
still brain rot. I mean,
What?
You know
Those
what
stuff.
you know what is brain rot? Nah, I wouldn't do that. I wouldn't do that. I'm not do that in class.
Yeah. No, it's brain rot. Playing Stealer brain rot on Roblox. That is brain rot.
Nah, Triple T is tough, bro. What are you talking about?
Whoever just played that
God,
game.
Rob,
Whoever just played that game.
Roblox is the definition. Is the definition of brain rot. I've never seen a more.
Thank you. I dabbing you up, even though you can't sing it just now.
Right. What is Roblox? Roblox is like
Roblox is trash.
Really?
I don't even
like my baby cousin, right? Well, I wouldn't can't really call him my baby anymore, but like he'll come up to me and be telling me like 6'7" or like Sigma boy or like what kind of sus things he hear on Roblox. Like Roblox is damaging people's brains, my guy. It's like ruining kids' brains. It's turning into mush.
Yeah, I hate the salesman things. But starters, I think they're annoying. That's what I think.
What's that again?
I think they're annoying.
Yeah, I find so too. Roblox is kind of like the epicenter of brain rot. It's crazy.
Oh, wait, no, not Roblox, but they mean themselves.
Ah, I see it. Yeah, kind of annoying, especially when they're very repetitive, for sure. All right, so Regina, you ready to help me? You ready to be locked in?
Yes, sir.
All right, so Regina, And you understand directions, you know how to go from one point to another point?
Yes, sir.
Great. Give the question and read for me.
Repeat, sir.
Yeah, give the question and read for me.
The diagram below shows triangle OPR. The point M is the midpoint of OP and the point N is the midpoint of OR. In the diagram, OM equal U and ON equal V.
Right, so Regina, let me soak this in. So M is the what of OP? Is the what?
Repeat, sir.
Right. So Regina, M is the what of OP?
The midpoint.
It's the midpoint, right? So it cuts the line segment
Two.
in half, right? Midpoint,
Yeah.
half. So that then they're telling us that O to M is U. O to M is
U.
the O to M is U. I'm gonna put an arrow, right? So we could see it for ourselves. So if O to M is U, what do you suppose M to P is?
M to P would be V.
Nah. What did they say V was?
ON.
ON. That can't. Nah. Oh, so O to N is V. But here I was asking you, right, Regina? Forget about this U1 thing, right? Forget about that. Imagine I had given you a line here, and I tell you the midpoint, that this part was 5 meters. How long would you tell me the other part is?
5.
Altogether, it would be what?
10.
Okay. So if you could tell me that, you could figure this out. So O to M is U. What do you think M to P is?
U.
M to P is U as well. That makes sense, right?
Yes.
Yeah, that makes sense. All right. And O to N is V. We know that N is the what? N is the what of O to R. N is the what?
N.
N is
That's
the
the midpoint.
and the midpoint cut something in.
Half.
So if O to N is V, what do you think N to R is?
V.
Correct? So are we cooking? Pile arrow here.
Yes, sir.
Pile arrow to indicate that. Who here would have gotten up to this part, up to this point? Who would have figured out this? Would anybody have figured that out?
Yes, sir.
Yes.
All right, Ria, is it like insanely, intangibly hard?
No, 11.
Okay. Mira, talk to me. Let me know what's going on.
11, not understanding, a grasping.
That's good. That's extravagant news. All right, so Regina, the next thing, they want us to go from where to where?
They want to, for number 1?
Yeah, part 1A. They want us to go from where to where?
M to N.
M to N. You know what I gotta do? Here what I gotta do, right, Regina? M to N. You see now, right? I got an arrow here.
Yes, sir.
So that's what I want to go. I want to go from M to N. So all this is just directions. That is all it is. So Regina, if I wanted to go from M to O, how are we doing that? What's in M to N? How would I go from M to N?
M to the origin
What next?
plus O to N.
Does could everybody see that? If you wanted to go from M to N, you'd have to go from M to O and then from O to N.
Yes, sir.
Yes, sir.
Okay. So, Regina, M to O is in the opposite direction to what?
which is the opposite direction of u, so it would be minus u
Perfect. I like your reasoning. Be negative u. Are we going
plus v.
correct? Because we're going in the same direction. Yippee! Who would have gotten this far? Who would have gotten this far? Apparently not a lot of people. Easy.
Me.
That's good. That's good. Anybody else? Like, I finally real quiet. Why are we so quiet for?
Of course, sir.
Jelani, you understand everything so far we cooking?
Yeah, cooking.
All right, now we're gonna look at N to P. N
So I
to
could do this one?
Nah, I'm gonna let Regina do it. Regina had asked for this question.
Okay.
Right, Regina, hear what? I'm gonna put on another line to just show myself where we want to go to. So Regina, you wanna go from where to where in the second part?
We're going from n to o.
Wait it. I'm not asking you that exactly. Like, okay, look at the path. So we wanna go from N to where?
We're going from n to p.
N to P. So I'm gonna put on our line to show that. So this would be N to P. How I could go from N to P, boy?
We're going from n to o.
Wait, I need some. Give me a second. I need some colors, man. Need some colors. Okay, okay. So if I want to go from N to P, well, it means that I'm starting from N.
To
Yeah.
o. Yes.
And then I'm going where to where?
From o to p.
So we on the same boat right now, right?
Yes, sir.
We're in Titanic. Gotta say no because the Titanic sunk. That we don't want that. We like
No.
we like we're like on a cruise ship. We're on a cruise ship. That's what we on. We're on a cruise ship, right? We're cruising through this. Listen, it's not hard. So if I want to go from N to P, notice that that is in the opposite direction to V. So what was that going to become?
It's going to be minus v.
And is this in the same direction as the U and the U?
Yes, but we're going to change it to 2u.
Exactly, because we have
Because
one over
the
here.
m splits it in the middle, so we're going to change it to 2.
Correct. So the NP is just going to be, I mean, if you want, you could write it full working. So that would be N to O.
Plus o to p
Which is,
equals minus v plus 2u.
guys, we're feeling good? Feeling good so far with this question?
Yes, sir.
Yes.
It's just directions. I tell it all. This thing easy, you know, it's just directions.
And it could also be set as 2u minus v.
Yeah. So like for those of you guys that had this instead, you're completely fine. If alternatively you had V minus U, that's correct. And if you had 2U minus V, you are correct. You are allowed to change around terms so long as you don't change the signs associated with them. So notice this is negative U and this is positive V. This is positive V and this is negative U. Still the same thing, still means the same thing. We didn't break any laws of maths. Tivon would approve. It's very legal. All right. Next question, Regina. And we should be able to answer this, right? Read part two for me.
Yes, sir. Show that mn is parallel to PR.
First thing first, I'm gonna put on what MN is. I'm gonna put on that. What is MN? Remind me.
Mn is minus u plus v.
Cool. And they mentioning another vector. Let me put that down too. PR. Do I have PR?
No, we don't.
We do have PR. So if we do have something, what we gotta do? Cry or find it?
We're gonna find it.
We're gonna find it. We're not gonna cry, right?
No.
We could do both.
Right.
Yes, you could.
Damn. That's valid. That's valid. So you want to go from P to R. So I'm gonna draw a little orange line here, so to speak. How could I go from P to R?
We're going to go from R to P. So it would be RO,
Wait,
R to the origin.
wait. P to R, eh? P to R. So where you starting from?
P.
Right, but you just don't tell me R.
Well,
Take your time.
wait. Oh no, I switched it around.
So
So it's going to be O origin to P, and then P to R.
nah.
No.
You,
All right, here for me, what I have is RO plus OP.
right. RO plus OP.
Plus OP. And that would be minus 2U
But
plus 2V.
wait, immediately I can tell you that wrong. You know why I can tell you that wrong? What are we starting from over here?
R.
And we ending up at
P.
what we want to go to?
PR.
P to R. Now you could always just invert the answer when you find it. But ideally we should figure it out one time. There's multiple answers for this, Like it's ridiculous how much answers you have for this. But I think the safest one here, Regina, is what I'm gonna show you. So Regina, again, we're going from where to where? Where to where?
We're going from O to P.
Wait. You're overthinking it. Read this literally, like read it literally. Yeah. So it says
P to R.
That's literally what it means. P to R. So I'm gonna put on my point by P because I'm starting from
P.
and I want to go to
R.
right. So how I could move next? Simpler than you think. It's probably looking complicated because of how much I draw in the diagram, but it's really simple, I promise. It's really simple. Look at this, right? How would you go from P to R?
I would go to the origin, but you said that's wrong.
Oh no, that's correct. But you were talking about O to P, which would not be correct.
Oh, okay.
So from P you could go to where?
From P, I could go to N.
Wait, you could go to the origin. The reason I was telling you where you was telling me I was wrong is because you were telling me O to P. But it wouldn't
Oh,
be
I put it the wrong way. So it would be P to O, and then O to R.
correct.
Okay.
Another way you could have take was P to N and N to R. Did anybody see that route?
Yes, sir, I did do that.
Right. And that's not illegal, because you check this, right? If you did it like this, you know what NP is. You know how to find for PN. PN would just be V minus 2U. You would just change the signs because they're going in the opposite direction. And well, from there you could just add V and you'll get 2V minus 2U. You get the answer one time. But Regina, this method I'm gonna show you here real simple, right? I promise you it's real simple. And you understand this one? If you want to go from P to R, P to O, and O to R. Make sense?
Yes, sir.
Okay. Now this U over here, and it was going in that direction.
Yes, sir.
And we also had a U here as well.
Yes, sir.
We also had a V here as well, and these were going in this direction. So talk to me. Are we going in the same direction here or the opposite direction?
Opposite direction, so it's going to turn into a minus 2.
And over here, opposite direction or same direction?
It's going to stay the same, so it's going to be 2V.
Perfect. So, long story short, PR will just be equal to what?
Negative 2U plus 2V.
Cool. That's it. But
I have it worked out here.
we still need
I
to
literally
show.
have it worked out.
Wait,
So that's where I went wrong. That's where I went wrong. See it here. That's where I went wrong. See here.
I'm struggling to see that. Kind of hard to see that because it's so tiny.
Sir, I'll send you the picture.
Yeah, somebody picture. So Regina, did you understand everything I did?
Yes, sir.
Bet, bet, bet. Okay, so now we know what PR is. We have that. We have that on lock. So PR is just equal to what?
Minus 2u plus 2v.
Minus 2u plus 2v. Now here is the question. They want us to show that they are parallel. Parallel means that I could write one as a scalar multiple of the other one. So by looking at this, I know it might be a bit hard to see, but by looking at this, you see any relationships? You could infer. Tell me, Regina, is there anything you could figure out?
Yes, sir.
Okay, talk to me. Like you could write one as what by something. So you could write one vector equals to what by the other vector.
Repeat, I don't understand.
All right, check this out, right? It sounds complicated when I say it, but the concept is simple. Let me show you what I mean. When you saw this example earlier, were you able to make the connection that OB would be equal to 7 times OA?
Yes.
You sure?
Yes, sir.
Well, it's the same thing we're trying to prove here. It just looks a bit more complicated. To help you out a bit, I'm gonna ask you this, Regina. Um, is it possible for me to factor out anything over here?
The 2.
We could factor out the 2. If I factor out the 2, what I write on the inside?
U.
Nah, no, no.
No.
It'd be what? It wouldn't be positive.
It would be minus
Minus what?
2u.
Nah, but you already pull out the 2, remember?
Oh, so it would just be minus u plus v.
Okay. You see minus u plus v anywhere?
Yes, it's in mn.
So I could replace, talk to Mara, I could now replace minus u plus v for what? Instead of writing minus u plus v, what I could write instead?
For PR?
Wait, none. Okay. Instead of writing minus u plus v, what I could write instead? What is minus u plus v?
I
promise.
generally don't.
Nah, it's simpler than you think. It on the screen, right in front of you. I promise.
Repeat the question. Let me see if I get it.
What could I replace minus u plus v for? What could I replace that with? Instead of writing minus u plus v, what could I write instead?
mn?
Yeah, mn. And in doing this, Regina, you would have proved that PR is a scalar multiple of mn, which means they're parallel.
Okay.
And looking back on it, I think you can see what I'm talking about, because if you multiply this by 2, you'll get. If I multiply mn by 2, I'll get
2 minus 2u plus 2v.
Which is the same thing
as negative 2u plus 2v.
For PR and
mn.
wait, say that again? Okay, I need to
It would be similar to mn.
wait,
because if we times it by 2,
Mm-hmm.
we'd get back the same answer.
We get back the same answer for what?
PR.
Correct.
But if we cancel out the 2, we get back our answer for mn.
Mm-hmm. So that shows that they are scalar multiples of each other.
Yes.
And again, just by looking at it now, you could probably see that, okay, if you want to get PR, you'd have to multiply this mn by what?
2.
Yeah. So you see why I say PR is just 2 times mn?
Yes, sir.
And you're probably saying, sir, well, I struggling to see it. You could make me see it a bit more. Okay, I could do that. It's not a problem. Let me do something quick. I wait to measure this length from here. That kind of looking like what?
So from 0 to
That looking like 1 point what?
7, 1.7.
All right, 1.7. Okay,
And
it is not like, okay, it's not a, they didn't draw the diagram to scale, right? They didn't draw the diagram to scale.
no, they
But
didn't.
I think you could see that, watch, this is MN, right?
Yes.
How much MNs it would take to make PR?
2.
Right, so PR is equal to 2MN, and you just prove that. So they're parallel. So generally
Yeah.
speaking, this is how you prove it in the exam. You'd have to factor out something, and then when you factor it out, you'd see that, look that vector there. You could do a substitution, and you prove it. So you fully understand this?
Yes, sir. I sent it to you, by the way.
What's going on in chat 66? What's going on in chat? Are they having a maths debacle? But anyways, Regina, how you feeling with respect to this? Regina?
Sir, I'm here.
You fully understand this?
Yes, sir.
All right, bet. Give me a second. All right. This question was too easy, but it serves as a building block because now we can understand vectors, right? Let's do a harder question, and I'll call this a day when I'm done with the harder question. Let me see what we had in 2020 now. Hope January 2020 had a hard question. Fingers crossed. Okay, yeah, had a nice question here. How nice. I need a volunteer for this. Who wants to help me with this question? It's a hard question. It's like a harder type of a question. Is what I expect in the exam this year. Any volunteers?
Sir, me?
Who's that?
Gary. Different.
Gary. All right, let me go, Gary. So we have a parallelogram, and it's telling us that P to Q is U. P to S is V. We cooking? You understand that?
Yes, sir.
I feel like I do this question before on my YouTube channel. This is the exact same question I did on my YouTube channel, is it not?
Uh-huh.
But I'll still explain it.
Yeah.
I feel like I'll still confused after watching that. So Gary, if it's a parallelogram, then opposite sides are equal. Agreed?
Yes, sir.
So P to Q is U. I would make S to R what?
U.
And I would make P to S and Q to R be what?
V.
V. And this is the tricky part. This is the part that is lose students every single time. They're saying QM to MS is 1 to 2. What does that mean? Okay.
Q to M is 1/3 and M to S is 2/3.
Perfect. Perfect. That is correct. Now, if you add up 1 and 2, you'll get 3. Yeah? You'll get 3. And what that tells you is that so this entire thing is QS. It's broken up into 3 parts. Out of those 3 parts, QM is 1 out of those 3 parts. So this will be a third of QS. And the second part, MS makes up 2 out of the 3 parts. So MS would be 2/3 of QS. So just to make sure we understand that, let's look at it in a different way that's more intuitive. Gary, can you see that QM kind of looks like half of MS?
Yes, sir.
Kind of a better way to think about it. So this is QM, right? How much QM do you think it would take to make MS?
2.
Yeah, watch. So altogether, I could break up QS into how much parts?
3
And
parts.
out of those 3 parts, QM is what of QS?
Q to M
Is what fraction of Q to S?
1/3.
Right, 1/3 of Q to S. I hope all you, I hope all you could, hope all you type in. Wait, when I finish that exam, I hope all you messaging. I hope all you message me as much as you messaging in the chat, low key. I want, because I see the chat really going active, like it's very, very active right now. It's very active. I just hope all you so active in the exam. Yeah. So Gary, QM is equal to a third QS. What do you suppose M to S is?
M to S will be 2/3.
2/3 of what?
QS.
Regina, are you feeling cooked? Or do you understand this?
A little bit of both.
Okay, no problem. But did this part confuse you?
Kind of.
Kind of. Well, it did. It did. Right. So this is the simplest way to think about it. If you add 1 and 2, yoga.
Yes, sir.
If you add 1 and 2, where would you get? Where's 1 plus 2?
3.
3. And this talks about this talks about Q to S, right? So when you look at this, can you see that Q to S is split into parts and M splits it?
Yes, sir.
All right. So for the entirety of QS, QM would be 1, it will be 1 out of the 3 parts. Because you're seeing when you add 1 and 2, you're gonna see 3. This tells you the amount of parts you have making up QS. And out of those 3 parts, QM is 1 out of those 3 parts. And out of the 3 parts, MS is how much?
1/3.
Nah. Okay. If I
No,
compare,
it would be 2/3 actually. Sorry.
check it
2/3.
out. 1 is QM and 2 is MS. So it's gonna be 2/3. But it's gonna be a third of what? It's gonna be a third of what? A third of what?
It's going to be what?
It's gonna be a third of what? What was the entire thing? What was the entire line we're talking about?
QS.
Exactly. You see, with me on the same page, you could big up yourself. So it's gonna be a third of QS, and it's gonna be 2/3 of QS. Probably saying it have an easier way to understand this. Yeah. Regina, how much QMs you think it'd take to make M to S?
For Q to M, it's going to take 1. But for M to S, it's going to take 2 because it's longer.
It kind of looks like it is like QM is half
I
MS.
can cut it in half.
So altogether, how much parts you have?
3.
And out of those 3 parts, QM is just what?
1/3.
Bam, 1/3, and MS is just what?
And MS is 2/3.
You fully understand it, right? You with me now?
Yes, sir.
Anytime you see this ratio thing, it suggests that
I must add and then find find how much it is for each.
Perfect. So QM is 1/3 is a third of QS. QS is the entire thing. And MS is 2/3 of QS. We good?
Yes, sir.
Cool. Gary, let me continue. So Gary, we want to find QS. QS. So we want to go from Q to S. I should probably take a screenshot of this before the diagram gets very, very messy. Okay. Diagram is about to get very messy. So I'm breaking it up into parts. So hopefully I don't lose any of you. That is the hope. So Gary, in your first question, we want to go from where to where?
Q to S.
That would be this red line over here, yeah?
Yes, sir.
How could I go from Q to S?
You could go Q to P, then P to S.
If I'm going from Q to P, am I going in the same direction as you or the opposite direction?
Opposite, so it will be negative U plus V.
Perfect. So Q to S would really be Q to P plus P to S, which we know to just be negative U plus V. We good?
Yes, sir.
People are paying attention. All you understand this?
Yes, sir.
Yes, sir.
Yes,
All
sir.
right.
Yes, sir.
Yeah, here's some people. That's good. That's good. We are alive.
Yes.
Regina, you fully understand this part. Like nothing confused you at all. You could get this correct in the exam.
Partially. I think I will get it. I don't have
Partially.
that much confidence.
No. I had to erase this thing then. If you feel partially. No. I don't like that partially thing.
You gotta
Regina.
be like, I could do this.
Yeah, that.
No, I don't have that kind of confidence.
Then how you want to get that kind of mark then? You had to build up the confidence.
No. Once I work it and I say, okay, that's good enough for me. But I don't have that type of confidence to say, oh, but I'm gonna pass that. No.
Regina, I believe in you. And you had to believe in yourself. So Regina, logically, you want to go from where to where?
Q to S.
Where we starting from?
We're gonna start from Q.
And I want to go to S. So how could I move next?
Q to P.
Cool, Q to P, and then how I could move after that?
P to S.
If we're going in the same direction, leave any sign. If we're going in the opposite direction, change the sign.
So
How?
it's going to be minus U and V.
Cool. So if you want, you could literally just write the answer, minus U plus V. But it's probably ready for working. So we're going from Q to P. And then
And then P to S.
okay, now tell me. You can get the question correct?
Yes, I did.
Clock it. Clock it. Yeah. You have it. You have it in the bag. You have it in the hat like a magician.
Still don't have that confidence, but okay.
All your what we gonna do original, boy? No.
It's just that the fact that when I understand the question and I got everything right and correct, for me to go in the exam now, everything just changed. I don't know what happened. So I just said, okay, then let's just leave it at that.
Practice. That's the best thing I could just tell you. Practice. Right? Okay. Q to M. Who knows more Q to M? Gary, you was in the question, mama. Gary, you there? Gary?
Yes, sir.
Gary, so you want to go from Q to M, yeah?
Yeah. So you could go Q to R. This might be a long way though.
You're saying Q to R.
Q to R to S, and S to M.
When I tell you how to do this, you'll be like, nah. You want to blow your mind?
Yes, sir.
Okay, let me go back to this, right? This ratio splits Q to S, right? And we know that, right? It splits Q to S. Tell me if we know that, Gary. Gary?
Yes, sir.
How much parts does QM get out of the three?
QTM gets 1/3.
So in other words, I could say that QM is what? QM is equal to what?
1/3 QS.
And I can say that MS is what?
2/3 QS.
Don't forget that, you know. So now they're asking me for QM. Where's QM? Remind me, Gary, where's QM?
1/3 QM.
Okay,
QS.
maybe you're doubtful. Maybe you don't fully see it. So bear with me. That entire thing is what? That entire red vector.
3 parts.
And that entire vector is Q to S, right?
Yes, sir.
But Q to M is how much of those parts?
A third.
Right. So that'll just be a third of Q to S. That's all. Do we know what QS is?
Yes.
What is Q to S?
So it's not 1/3 QS, then 2/3 QS.
Say that again?
So it's not 1/3 QS, then 2/3 QS.
Nah. I feel like you're severely overthinking this.
Oh,
So
right. It'll
wait.
be
Tell me.
minus U plus V.
Nah. All right. So Gary, do we know what the entire vector QS is? Do we know what the entire vector for QS is?
Q to P, then P to S.
And what did I get for that?
Minus U plus V.
And QM is what?
A third QS.
Where's QS? Yeah, I really feel you overthinking it. It's real simple. QS is just minus U plus V. Gary, let me know if you understand what I'm saying.
Yes, sir.
You sure? It will sound like a person that catches it, that gets the eureka moment. Like, you sure you understand that? Like, watch. QM is just a third of QS. And well, we could see that. QM is a third of the entire thing. Do we know what QS is?
Yes.
What is QS?
Minus U plus V.
It's sounding unsure, but and if you take minus U plus V, we're going to end up at
QS.
right. So QS is just minus U plus V. That is all. And so in the next question, I could replace QS with what?
A third minus U plus V.
Because QS is
Because QS is.
Excuse sir.
yeah, Joshua.
For B, QM equals to QS.
That part confused you.
Why a third exactly?
Say that again.
Why a third?
All right, no problem. Let me explain that quickly. All right. So Joshua, they said here that M is a point on QS such that QM to MS is 1 to 2. So, Joshua, what does that mean? So that means that they're splitting up QS. So they're going to split up QS. Now, to figure out how much parts they're splitting up QS into, you're going to add the ratio. So Joshua, what is 1 plus 2?
3.
3. And, okay, I'm going to write the ratio here. So QM has how much out of the 3 parts?
Where's QM reach?
Wait, how much out of the 3 parts, how much does QM have?
1.
And out of the 3 parts, how much does MS have?
2.
Ah, so QM would just be a third or what?
A third of 2.
Nah. Remind me, Joshua. We splitting up what line? What was the line we splitting up? Okay, maybe you might see it more visually. So Joshua,
QS.
yeah.
This is yours.
All right.
Johnny's.
All right. Yeah. So Joshua, can you see that this is QM?
Yeah.
Now QM looks as though it's half of MS. Yeah or nah?
No.
Nah. Okay. I'm gonna try to visually show you that it is that. Right? Let me show you that visually. So that's QM, right? Joshua, you see what I'm talking about now?
Yeah.
How much QMs did it take to make MS?
3.
Nah, it take me 2. It take me 2. I'm gonna show that again, right, Joshua? So that's QM. This is QM over here, right? This is QM over here. Yeah?
Yeah.
It take 1 and it take the other one. So Joshua, how much
Okay.
parts?
Fine.
How much parts did I split up QS
2.
into? How much parts did I split up the entirety of QS into?
Into 3.
Right. Out of the 3, how much is QM?
1.
So wouldn't that be a third of what? Be a third of what?
Yeah.
Be a third of what?
3.
Nah, it wouldn't be a third of 3.
Okay. 2. 2. 2.
Nah, it wouldn't be 2. So Joshua, remind me, we're splitting up what line? What line are we splitting up again? Was the entire line?
QS.
Right. So this is the entire QS, right? If we are talking about QS, then that would be what fraction of QS?
Third of QS. Yes.
So that again?
A third of QS.
You're correct. That would be a third of QS. Right? So QM is a third of QS. Brilliant. And so if QM is a third of QS, what do you think MS is?
2/3.
Correct, because it has 2 out of the 3 parts. So does that answer your question as to how I get a third QS?
Yes.
So you fully understand that. So like this is break up into 3 parts. And out of the 3 parts, this is just 1. So a third. And this is 2 out of the 3 parts. So 2/3. Right. Now, Gary, I feel like you still don't understand it fully. So Gary, I'm gonna ask you. What were they asking us to find any first question?
And also, I have also a question.
Yeah, Joshua?
What time are we ending exactly?
Well, as soon as we're done with this question.
Oh, okay.
Yeah, Gary, I feel like you don't fully understand it, which is fine, but after today you had to understand it. So Gary, when you read the first question, what is the first question asking you to do?
Q to S.
In terms of what?
So wait, what do you mean in terms?
I read the question, and you will see what I'm talking about.
Q to P, then P to S.
Read the line before that. I mean, what's it? Read the line above it. Read the line above it.
Right in terms of U and V, an expression for Q to S.
So Gary, all my answers need to be in terms of
U and V.
right.
So you're going in the opposite direction, so it's minus U and plus V.
So QS is just
minus U plus V.
so anywhere I see QS again, instead of writing QS, what am I gonna write?
So repeat.
So anywhere I see QS, what am I gonna write instead?
Minus U plus V.
Right, because that's what QS is equal to. So do you
Yes,
want
sir.
any second part? I replace QS for what it was
Yes, sir. That makes sense.
because they want the answer in terms of
U and V.
correct. So I wrote my answer in terms of,
U and V.
and we know that QS was minus U plus V. Everything is sure everything makes sense?
Yes, sir. It makes sense.
100%.
Yeah,
Okay,
100%.
nice. And if I expand these brackets, what would that give me?
It will be a third minus U.
Minus a third.
And a third plus V.
Correct. Let me move on to this part. So show that M to R is a third U plus 2V. After this question, I had to go because I had to start a class immediately after. Right. So Gary, I'm gonna connect M to R, right? Because we're trying to find M to R. Agreed?
Yes, sir.
So if we want to go from M to R, how could I move?
M to S to S to R, or
That's legal, that's completely fine. But you see, the thing is, now you would have to find MS. Remind me, MS is just what of QS? MS is what?
2/3 QS.
You see, you'd have to go and do an extra calculation. That is correct, but it is intensive. How else could you go from M to R?
M to Q, then Q to R.
Would it be easy for me to find M to Q?
So it won't just be a third QS.
Nah, that's MS you're talking about. Remind me, what do we find for any last question?
Q to M.
So would it be hard for me to find M to Q? Yeah or no?
No, so it'll be easy because it'll just be a third minus U plus V. The
Well,
previous answer.
it wouldn't be a third minus U plus V, but it will be okay. Wait, let me take your time. So remind me, what is QM again? Talk to me. What is QM? Q to
A
M
third minus U plus V.
minus a third U plus a third V. So if I'm going in the opposite direction now, say M to Q, what do you think that'll be equal to? Anytime you go in the opposite direction, what do you do?
Negative 2 plus U. Wait.
Let me show you a simple example, right? So P to Q is U. Q to P is,
Negative U.
we do these signs.
Minus.
We change the signs, right?
Change it. Yeah.
So it's the same concept here. Q to M and M to Q. They're more or less the same thing, just different directions. So what am I going to change this to?
Just a third plus negative one third. Well, just negative one third.
Ah, you understand what I tell you? We already had that and it was easy to find.
Yeah.
If you went down the other route, it'd be correct, but you're occupying more time in the exam, which is costly. All right. So you understand that we have Q to M, and using Q to M, we were able to find M to Q by just switching the signs. Yeah or no?
Yeah.
Ah, so we have this. Do I know what this arrow is?
Yes, sir. That's just V.
Ah, okay, cool.
Positive.
So M to R is just, will you tell me, M to
M to Q and Q to R.
remind me, what is M to Q?
A third U minus a third V.
And what is Q to R?
Plus V.
Could we simplify this?
Yes.
Any like terms over here?
Yes, sir. A third V and the extra V.
Right. So in the calculator, you can put minus a third plus 1. And when you do that, you should get 2 over 3. So it's going to be a third U plus 2 over 3V. Another way to think about it is 1 is the same thing as 3 over 3. Since they have the same denominators, it's essentially minus 1 plus 3. Minus 1 plus 3 over 3, right? Minus 1 plus 3 is 2. 2 over 3. But we're not.
Okay.
Say that again?
Okay, sir. That makes sense.
Yes. Okay. Just to make sure we're not confused, right, Gary? Gary, how much V's do we have here?
This is one V.
That is 1
And
V.
this is the third V.
So is minus a third plus 1. That just be,
Sir, repeat.
what is minus a third plus 1? Minus a third plus 1. That's not something you
Two
could,
thirds.
yeah, that's not something you have to do in your head. You just plug it into your calculator. But
Yes, sir.
we're not done. This is what we wanted to prove. This is what we wanted to prove. This is what we wanted to prove. So what do you think I could do next? Tell me, Gary, what do you think I could do next?
Distribute it to see if I get the same answer.
Now, in proof questions, you need to get that. It would give you the same answer, but you need to get that. So what do you think you should do to get that? You need to get this.
Break it down.
No, you already break it down. You can't really simplify that. But okay, how could we go from this line to this line? Or I mean, what I'm saying, how could we go from this line to this line? I had to do what? Starts with F.
Factorize.
Yeah. Yeah, I could factor out what? What could I factor out from a third U and 2/3 V?
A third.
Yeah, a third. If I pull out a third, what I write on the inside?
U plus
What by a third would come back 2/3?
2 thirds. 2 thirds V.
Wait, what would I multiply by a third to get back 2/3?
2.
Right, so U plus 2V. That's the
Yeah.
answer. That's it. I mean, if you understand that.
Yes, sir.
Right. Yeah, sure.
Yes, sir. I understand. It just was a little bit, is plenty work, but not really plenty work here, but you know what I mean.
It's a little hard to see. I understand, I understand. I tell you, like one of the biggest ops is factorization on fractions. But let me explain something, right? So all might be confused here. Probably saying, so how you could pull out a third? Well, we have a third u, and 2/3 is the same thing as 2 multiplied by a third v. So you can see a third here and a third here. And Gary,
Yes, sir.
if I pull out a third, I'll just be left with u here, and then I pull out the third, right? So what we right here?
2v.
Yeah, that's it. Doesn't make sense.
Yes, it makes sense.
Okay, cool. So this is a tricky question, and I'm giving you all this for homework. Like, if you think it's correct, you can go on my YouTube channel, and I did the answer for this question, so you can check it. But this is all your homework. Does everybody understand vectors a little better? Like a little better?
Yes, sir.
I don't expect miracles,
Yes,
but
sir.
Yes, sir.
all right. So let me just do a little summary, right? If I want to show two vectors are parallel, what do I do?
Find a scalar multiple.
Not necessarily find the scalar multiple, but I need to write one vector as a
Pick one
scalar
vector.
multiple. I need to write one vector as a scalar multiple of another. So,
Yes, sir.
but I think you know what I'm talking about. You tell me the correct thing. Um, are all parallel vectors collinear?
No.
No.
And vectors could be parallel, but not on the same line.
Yeah.
Yeah. What would make it collinear?
Points line on the same line.
Exactly. If I have this vector here, and then I have another vector that's also what? You understand? Like both of these vectors parallel, but they start from the same point. So you know the points along that line are collinear. Like they're on the same line.
So I have a question.
Yeah, Jelani?
I remember from a class where we did vectors, we touched on magnitude and unit vector.
Yeah, that should
Is
be
that
that should be in notes, right? But like, can I
okay?
explain it to you quickly? So like, you know about unit component form?
Yeah. So
So like, let me just say about vector A, and vector A is 7i plus 3j. If you want to find the magnitude of that, it's just going to be square root of, well, okay, first you have to understand that this is in the form xi plus yj. So to find the magnitude is just x squared plus y squared, and find the square root of that, which comes from Pythagoras theorem. So that's just going to be 7 squared plus 3 squared. 7 squared is 49. 49, that's square root of 58. That's the answer. Now, if you want to find the unit vector, which is a top part, is just the vector, the big vector, divided by the magnitude. So that'll just be the entire vector, which is 7i plus 3j divided by root 58. If you want, you can split it up in the parts, and you can say 7 over root 58, I, and that'll be 3 over root 58, g. And the special thing about the unit vector, if you find the magnitude for this, it's supposed to get 1. All unit vectors have a magnitude of 1. Hence the name unit vectors, because the magnitude is 1 unit. That's like as quick as I could. I had to go
yeah.
now.
So
I had to
so
go.
one more thing. Is the last thing necessary to put in the exam? You could just leave it as the second one.
I advise you to write it like this.
Okay. All right. Thanks.
Yeah, but this is all your homework. Later, guys. Take care. See you all in the next session.
Later,
And
All right.
sir.
Bye, sir.
see you all in
Yep.
the crash course.
Sir.
Later.
All right, sir.
Yeah,
Bye.
any crash course, yeah.
Yeah, later.
Later.
Bye, sir.
But the meeting don't want to end. Are you still here, man?
Bye-bye.
Wait, are you hearing me?
Sir?
Are you hearing me? Yeah or no?
Yes, sir. Sir?
Yeah, are you hearing me?
Yes, sir. I'm going to send you a paper and I'm going to ask for you to look at it, please.
You're gonna send me what?
A paper.
Paper? Okay. Wow. I'm real busy, so I'm gonna finish class like around 11 tonight. And then
That's fine.
yeah.
That's fine.
But yeah, guys.
Okay. Thank you.